Hey everybody, here's a video. I'm just going to try to help you with what we did last time, solving systems of equations, and where one of them is a quadratic. That can be pretty challenging. So I want to talk about how we solve systems. I'm going to do a review of solving systems of linear, which is going to teach us our strategies. And if you watched the help video I posted last time, I talked about that there's nothing new that you're really learning in math right now. Everything is an application of something that we've already done. So try to think about everything that you've already learned and apply it. Be creative. Don't be afraid to reach outside what you think you need to do and pull something in to try and see if it works. And if it doesn't work, try something else. In fact, after this chapter right here, there is not anything new that you're going to learn until probably second semester algebra 2. Okay. Everything in geometry is an application of Algebra 1. There is not a single new concept you're learning that isn't about shapes. Algebra 2, first semester, is all applying stuff that we've already done in this class, just making it a little bit different or a little bit more challenging, but it's the exact same math, but just a little bit harder. Okay, so you're going to have to factor, but the factoring's the same. It's just going to add an extra variable or something. Like you can do all of this stuff. There isn't anything new. Okay. So in fact, you actually know about 90% of the math you need to take calculus if you understand everything from Algebra 1. Like that's how critical this class is, which I told you from the beginning of the year. Everything else you're doing in math pretty much through the end of Algebra 2, you've already learned. So try to focus and also remember not to panic. This is all stuff that we've done before, so that means that it's in your brain somewhere. And I'm not saying that to make you feel bad, I'm telling that to help you, right? So don't panic on this stuff. Let's talk about how we solve systems before, solving systems of equations. So there was 3 methods we talked about. We talked about graphing, talked about elimination, and we talked about substitution. Now 2 of those methods are really hard to use. Graphing is actually easier than elimination in this one. So graphing is not bad if you're feeling pretty confident in your graphing ability of quadratics. If you're not feeling great about graphing, don't use that method. Elimination won't work. And substitution always works. So it's a good method, and we're going to review substitution today because that's the method that I'd like you to use in solving this worksheet. Okay, so substitution, remember, if I know what one variable equals, I can plug it into the other equation. So right here, I have an equation. It says y equals 2x plus 5. Remember, the equal sign means the same, which means this whole thing right here is equal to y. It's exactly the same as y, which means every time you see a y, you can replace it with 2x plus 5. Now I could replace the first y with that, and I get something like this. 2x plus 5 equals 2x plus 5. Notice that y is now gone, but this is kind of a boring equation. I know something is equal to itself. That's not very interesting. But what I can do is I can say this other y, those are the same variable, which means every time I see a y, I can replace it with this, and here's a y, which means I can replace it with what y equals. So I'm going to replace that whole y with the 2x plus 5. So this y is now gone, and it's been replaced with 2x plus 5 because that's what it equals. And now I have something a little bit more interesting. Now I can solve. All right, so I'm just going to get all my variables on one side, all my x's or all my numbers on the other. So maybe I'll add x to both sides so I can keep my x positive. 2x plus x is 3x plus 5 equals negative 1. I'm going to subtract 5 from both sides and end up with 3x equals negative 6. And I'm going to divide by 3. And I get x equals negative 2. And that's what x equals, right? So I want to plug that back in because this is now what x equals, right? Because equals means the same. So every time I see an x, I can replace it with a negative 2. So I'm going to go ahead and plug that back in. This first equation looks a little easier because there's no negatives in it. So I'm going to replace x in this first equation with negative 2. So let's say y equals 2. Instead of an x, I'm writing negative 2. Plus 5, so that's negative 4 plus 5, or positive 1 equals y. So now I have the intersection point. I have y equals 1 and x equals 2, we always write that as a coordinate. Because what I'm looking for here is the intersection point of these two. If you were to graph it, you could probably see it pretty easily. They're not hard to graph. The first one, 2x plus 5, it's going to have a y-intercept of 5 and go up by 2 each time. I'll do that in red. And go up 2, so it's going to look like this. And the other equation is negative x minus 1. So that's a negative 1 y-intercept. And it's going to go down 1 over 1. So you can see right here, again, this graph isn't perfect, but it makes sense that it would be about negative 2, 1. That coordinate makes sense. Okay, and if you have graph paper, it's a great strategy to use if it's easy to graph. And sometimes quadratics are easier to graph than others. If you see something in vertex form or it's easy to find the vertex, then you can try this method. Because a lot of times it'll be whole numbers. Sometimes it won't, in which case you're going to have to use substitution. Cool thing about substitution, which we just did here, it always works. All right, so let's look at the, I'm just going to do one question for you because, again, I have the explanation there. But we're going to do question 3. I think that's a pretty good application here. So we have y equals, on this problem, x squared minus 7x plus 13. And this is x minus y equals 2. Now, I'm going to see if I can get both of them equal to y like I had in the last one. If I can get them both equal to y, it's going to make everything a lot easier. So I'm going to try to get y by itself. Right now, subtract x from both sides, I think, on this one. Because this already equals y, so I don't need to touch it. I'm going to see if I can move this one around a little bit. So I have negative y equals 2 minus x. Remember, that's a negative 1. This is not y by itself. It means I need to divide or multiply both sides by negative 1. So I'm going to divide both sides by negative 1. Remember to do the entire side. It's going to divide into both pieces. Here, it cancels out, and I get y by itself. 2 divided by negative 1 is negative 2. Negative x divided by negative 1 is positive x. So now I have y equals in both. And remember from last time, once I know what y equals, it equals this, I can replace every y I see with this. And there happens to be a y up here, and I can replace that y with negative 2 plus x. That's what I'm going to do. I'm going to go ahead and plug that in. So instead of this y, I'm going to write negative 2 plus x equals. And then the other side is the same. So x squared minus 7x plus 13. Actually, from this point on, this question, believe it or not, is something that we did 6 weeks ago on a homework problem. It was a homework problem. I just changed it into a system of equations. Now remember, whenever you're solving a quadratic, you need to get 0 on one side first. If you don't have 0, you can't do anything. So I'm going to get 0 on one side first by adding 2 to both sides, and I'm going to subtract x from both sides. So all of that cancels out and makes a big fat 0. So now I have x squared. 7x minus x is negative 8x. 13 plus 2 is 15. And now I can use the quadratic formula. I can factor. Another method that I didn't teach you is completing the square, which if you'd be interested in learning about, let me know. But it's a third way of solving quadratics. You still need to get 0 on one side, though. This one to me looks really easy to factor. I'm looking for things that multiply to be 15 and add to be negative 8. Because again, I don't have anything other than a 1 right here, so I don't even need to do any hard math. This is the easy factoring. I don't need a generic rectangle or anything else. Just put the x's there. 15. If I know it multiplies to be positive, adds to be a negative, I know both have to be negative. And you can just brainstorm here. 1 and 15, that's negative 16, that doesn't work. 2 doesn't multiply to be 15. 3 and negative 5. Hey, look at that. Multiplies to be 15, adds to be negative 8. We got it. Remember, both of those equal 0 because of the zero product property, which we've talked about at length. means 0 equals x minus 3, or 0 equals x minus 5. You just solve those, and you get x equals positive 3 and x equals positive 5. And you've got some answers. However, remember, this isn't the answer. We're looking for the intersection point. That's what we're trying to do here. Remember, when you're solving a system, you're looking for the intersection point. The problem is on this one, we've got a parabola and a line. And it was 2 minus x, wasn't it? No, it was negative 2 plus x. So going to be something like this. I'm going to have two intersection points. So if I have an x here of 3 and an x here of 5, that's two separate y coordinates I need to find. I need to plug each of them in separately and find them. Right? So I don't know what the y coordinate is on either of those intersection points. But if I have a parabola and a line, you can have two intersection points. So make sure you plug in both pieces and find both y's. So I'm going to do that now. And you can plug them into either one, because when you're looking at a parabola and a line, again, this is just an estimate. I don't really know what it is, but something like this, right? The x and y coordinates are going to be the same for both the line and the parabola, so you don't have to plug them into this one. Plug them into the easy one. Let's plug them in here. Or you can even plug them into the new one, which I prefer because it's even easier to use. So I'm going to plug the first one in. I have negative 2, and then instead of an x, I'm replacing it with a 3 because that's what I solved. X is equal to 3 and 5, so I'm going to plug those in for x. So instead of the x, I'm replacing it with a 3, and now I can solve. Negative 2 plus 3 is 1, so y equals 1. That means my first intersection point, this one right here, that intersection point's got to be the x coordinate of 3 and y coordinate of 1. I'm going to do the same thing, but I'm going to plug in the other x value we found. Y equals negative 2 plus 5 this time, which means y has to equal 3. So that means my other x coordinate is 5, and the y coordinate is 3. That's this one right here. So you get two intersection points. Okay, remember when you're solving a system, you're looking for the intersection points. Okay, the last problem is a little bit trickier. Just so you know, if you do number 4, you will need a generic rectangle to factor it, or you'll have to do the quadratic formula. Either one works. But again, for my money, factoring is way faster. I mean, if you think about it, at this point here, you could have done the quadratic formula right here to solve this. Or I could do one step and factor it and solve way, way faster. So if you can factor, it's always faster and easier than the quadratic formula. You're less likely to make mistakes. But sometimes you can't factor, or sometimes your brain isn't working and you can't factor. Remember, you can always do that. Plug it back in, find your y's, you're good to go. Looking for intersection points. All right, that's it for today's help video. Hope this works for you guys. Talk to you soon.